We're going to take a look now at numbers 9, 10, and 11. So in number 9, the probability that merchandise stolen from a store will be recovered is 15%. Suppose a random sample of 8 stores from which merchandise has been stolen is chosen. We want to find the mean mu of this probability distribution. And in order to answer part A, we first have to decide, is this a regular probability distribution or is this binomial? So in thinking about whether or not it's binomial, we need to address those 5 conditions. Are there a fixed number of trials? In this case, we're looking at this random sample of 8 stores, so we could say that is our fixed number of trials, and we need to know, are these independent trials? Since we're taking data from 8 different stores and each merchandise has been stolen, I think we can say that this is independent. The probability of success, so the probability that merchandise will be recovered is 15%. We could say our success is the merchandise is recovered, and then we can say that that probability is constant at 15%. We can call this binomial, which means that the formula we use is n times p, so 8 times 0.15 is approximately 1.2. So we would expect 1.2 of these stores to retrieve their stolen merchandise. And then to find the standard deviation sigma, we're going to use the formula square root n times p times q. In this case, we already know n times p is 1.2, so then we multiply that by q. Q is 1 minus p, so 1 minus 0.15 in this case. So we're going to have the square root of 1.2 times 1 minus 0.15. And that gives us approximately 1. So our standard deviation is about 1 store. Looking at number 10. Of those people who lost weight on a diet, 90% gain all the weight back. In a random sample of 12 dieters who have lost weight, what's the probability of each of the following? Again, we want to look, is this binomial? We could say the 12 dieters is our fixed number of trials. Since each person is different, we can say our trials are independent. We could say that success, a little differently than you might think of success, but here we're going to say success is gaining all the weight back. And our probability of success in this case is 90%. So again, when you define success and failure, success doesn't have to be something positive. It can be something negative. In looking at A, we're looking for the probability that all 12 gain the weight back. So I'm going to go to my sheet and I'm going to say this is an exact number, all 12. So I'm going to use binom PDF on my calculator. So to get to binom PDF, I do second vars, alpha A, and I can see up here it matches. I wanted PDF and it says PDF up there. We have 12 trials, a probability of success of 90%, and we're looking to see if all 12 gain that weight back. What's that probability? And I get about 28.2%. Notice I am taking the time to write down my calculator input. Again, if something goes wrong in your answer, it's important that you've told me what your input was, and you'll actually be writing this by hand so that I can determine, exactly maybe where you went wrong in your process, and so that I can assign you some partial credit. In part B, we're looking for at least 9 gain the weight back. So we have an R value of 9, and on our sheet, we're going to match that to the language of at least. That's number 4. So I'll go to my calculator and I will type in 1 minus, and here notice we're doing binom CDF, which is alpha B. We have 12 trials. We have a probability of success of 0.9, and here we're looking for r minus 1. Our r is 9, so I'm going to type in 8. And I get this probability of 97.4%. So of those 12, having at least 9 gain back all their weight after their diet is 97.4% chance of that happening. In part C, we see we're looking for the probability that no more than 6 gain all of their weight back. So we want no more than, which is number 2 on the sheet. And this is binom CDF, so I'm going to go to alpha B, 12.9, and now my R is 6. And notice in this answer I got some scientific notation. I do need in my final answer, like if this was your quiz, to convert that scientific notation. So it says E negative 4. That means the negative means I'm moving the decimal point to the left, and the negative 4, or the 4 means I need to do it 4 places. So I take that decimal and I move it 1, 2, 3, 4 places to the left, which means this has 3 zeros in front of it, and then a 5, 4, 1, 2, 3, the rest of the decimals. If I wanted to make this a percent, I could move it back 2 places. So that would be 0.054% chance, that's real low, that no more than 6 gain the weight back. And then if we look at part D, we want to find from 8 to 10 gain the weight back, including 8 and 10. We see here number 6 is between 2 numbers, where A is the small number and B is the larger number. So we're going to use number 6 from the sheet. B is the larger number, so that's 10. A is the smaller number. So I'm going to do binom CDF, alpha B, 12 trials, probability 0.9, and I'm going to put my larger number in first. Then I'm going to subtract binom CDF with, notice it's not the smaller number, but it's the smaller number minus 1. So instead of putting in 8, I'm going to put in 7. So if you have an older calculator, your input should read binom CDF 12, 0.9, 10 minus binom CDF 12, 0.9, 7. And we get a probability of 0.336668405. The probability that from 8 to 10 of these people gain the weight back is about 33.7%. Alright, in number 11, a meteorologist found from the past year's record that it rained 17% of the days. Based on this information, what is the probability that for a random sample of 15 days, it rained 3 of them? So again, I'm going to identify this as binomial. The 15 days is our n, the 3 is our r, and we have a probability of success of 0.17. So we're calling success that it rained. So I'm going to go to my calculator. I'm looking for an exact value this time. So I'm going to do binom PDF. Second vars, alpha A. We have 15 trials, 0.17. And then R successes. So I see it's about 2.238, which matches answer E.